In this episode, we're going to look at how to use ICMP to test and correct network connectivity. I'll show you how to do it, and we'll talk about the concepts along the way. Customers have been complaining that they can't reach some of the network resources. We have been asked here to test the connectivity in our network. We're going to use ICMP to find out which resources are unreachable and the locations from which they can't be reached. Then we're going to trace to locate the point at which the network connectivity is broken. Finally, we're going to fix the errors we find and restore connectivity to the network. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Use ICMP to test and correct network connectivity. I have the Packet Tracer lab open. On the left side, I have our work area where we have all of our devices on our network. We can do our configuration and troubleshooting there. On the right side, I have the Packet Tracer activity window. Now, I don't have the Word document open this time because there are no answers to fill out. We're just going to do troubleshooting, and we do it until the network is working and set up correctly. Here we have an addressing table. This is what all the addresses should be. This is how the devices should be configured. If they're all set this way, our network should work correctly. The objectives in this lab. We're going to use ICMP to test our network connectivity and locate problems. We're also going to correct simple configuration issues and restore connectivity. Use ICMP to locate connectivity issues. Configure the network devices to correct any issues. Once again, ICMP, these tools that we're going to use is either ping or traceroute. Those are the two tools we're going to use to go in, figure out what's wrong with our network, fix it, and then test it again to make sure it works. Background here, we've got some complaints that some people can't reach some of the resources on their network, and so they've called us in. We're going to come in here and fix it. Here's our instructions. Wait till all the lights are green. It's been up and running for about 2 minutes now. All the links are green. None of them are amber, that yellow-orange color where they're going through a port negotiation. Select a host. Use ICMP ping to determine which hosts are reachable from that host. If a host is found to be unreachable, use ICMP trace to locate the general location of the network errors, locate the specific errors, and correct them. So we're going to use ping to see if we can reach the hosts. If we can't reach the host, then we're going to use traceroute to do that. As we look at our network over here, we can notice that we do have a couple different areas in the network. We have our WAN area, the area serviced by these three routers and the internet and our corporate servers. So this is sort of the WAN area. Then down here in the bottom left, we have an IP version 4 network. And over here, we have an IP version 4 network, one on switch 1, one on switch 3. And then for switch 2, we have an IP version 6 address. And for switch 4, we have another IP version 6 address. And so looking at this, all these devices here on the IP version 4 network should be able to communicate with all these versions or devices over here. And same thing with the IP version 6 network. All the devices on this network should be able to communicate with all the devices on this IP version 6 network there. What I'm going to do is I'm going to pick out a host. I'm just going to pick out the first one here, PC1. I'm going to click on it, slide it over, make the window a little bit bigger, open up my command prompt, and then I'm going just to start devices to ping. First one I'm going to do is I'm going to ping laptop 8. That's on my local network. It should work. And so ping IP address for laptop A is right here, 10.10.1.20. 10.10.1.20. There it is. That works. There's no connectivity issue there. Then PC1, I'm going to ping the other devices over here on the IP version 4 network. First one here is going to be PC4. Once again, ping, and then, what did I say, PC4? Here's the IP address for PC4, 10.10.5.10. 10.10.5.10. 10, I gotta retype that over, 10.10.5.10. Okay, this is not looking good. We have a request timed out. And we're still waiting. We have a second one. And a third one. And finally, the fourth one is going to probably time out also. So we have 100% loss when we go and ping PC4. And if we look at this, PC4 from PC1 comes up here through the switches. There's no IP addresses, so we don't need to worry about connectivity there, but it goes to router 2, then the router 1, then the router 3, and then down to PC4. Let's go ahead and do a trace route and see where that communication breaks down. And so the command here again is TRACERT, and then you put in that destination IP address. We put in the IP address for PC4, which if we look up here, that was the last IP address we tried to ping, 10.10.5.10. 10.10.5.10. And we're going to start off with the trace route. And we notice the first hop worked, the second hop worked, the third hop worked. But then we start timing out after that. And what that means here is from PC1, router 2 was the first hop. That worked great. The next one, the second hop here is router 2. Or sorry, router 1. And then the third hop we got to was router 3 here. Router 3 is our third hop. And if we look here, the third hop, the last successful IP address is 10.10.3.2. We look for that address here, 10.10.3.2 is right here. That was the last successful ping we got in our trace route. I'm going to go ahead, hit Control C. I'm going to break out of that. And then, once again, that means we are able to successfully get there. Typically, that means the error, the problem is after that. Well, the only things after that is the switch, which just passes through data. There's no configuration on it. And then it's PC4. Well, that leads me to believe that maybe it's something wrong with PC4. So I'm going to go ahead and click on PC4. I am going to open up the command prompt. And in here, I'm going to type in ipconfig, all one word, no spaces. That's going to list out our IP version 4 address. And right here, we have our IP version 4 address, 10.10.5.10. That was the address we tried to ping. We have our subnet mask and our default gateway. If we check our addressing table over here, here is our information, 10.10.5.10. That was correct. Our subnet mask at 255.255.255.0. That was correct. And then we have our default gateway. Our default gateway is 10.10.5.1. 10.10.5.11. Uh-oh. I must have typed it in because somebody typed in the 1 twice. And so what we need to do here is go in and change that default gateway. I'm going to close the command prompt here on PC4. To close the command prompt, you see the blue line right here. Click on the X on the right side. Click on IP configuration. And then set the default gateway correctly. And once again, our default gateway, if we look at our addressing table, is 10.10.5.1. Up here, it's 10.10.5.11. Go ahead and make that change. Close the IP configuration window. Minimize that down. Go back to PC1. And let's ping that address again. So ping 10.10.5.10. And there it is. We identified one problem and we fixed it. That takes care of pinging to PC4. The last device right here is on the IP version 4 network is server 1. PC1 is going to ping server 1. Ping, and then here's our address, our version 4 or IP version 4 address here of 10.10.5.20. 10.10.5.20. Well, that's not working. So What we're going to have to do again here is enter in the traceroute command and traceroute to that and see where this process breaks. Wait for the fourth and final one to give us 100% failure. Command once again is TRACERT space, and then the address we were trying to go to, 10.10.5.20. We go through the first hop, we go through the second hop, we go through the third hop, but then we start having problems. Once again, from PCA, this is the first hop, router 2 is the first hop, router 1 is the second hop, router 3 we successfully reached is the third hop, but then the error typically happens after the last one. And so that means, what is the error? Well, it's probably down here with the server at that point in time. Well, let's go look at the configuration here for the server. I'm going to go ahead and click on the server, make the window a little bit bigger, open up the command prompt, and type in ipconfig, all one word, no spaces. Here's our IP version 4 addresses. Look at that. It is set to auto configuration IP address. What that means is it's set to obtain its address automatically from a DHCP server. Well, that's not giving us the correct address. We're going to have to go in there and change it. I'm going to go ahead and close the command prompt here on server 1. That's the X on the right side of the blue line. Click on IP configuration. And if we look here underneath IP configuration, this is for IP version 4, it's set to DHCP. What we want is the manual or static. And so I'm going to go ahead and enter in our information, 10.10.5.20. Our subnet mask here of 255, 255, 255.0. 255, 255, 255.0, 3 255s. And then our default gateway of 10.10.5.1. 10.10.5.1. Going to go ahead, close this out. Go back to PC1. And now I'm going to try to ping that address again. Ping space 10.10.5.20. And there it is. That works. We took care of our second error. We've pinged all the IP version 4 addresses on our network. That means that's all working. Let's start looking at the IP version 6 networks. I'm going to go to PC2 here because that's the first one listed going left to right. Open that up. Open up a command prompt. And then I'm going to ping the IP version 6 address here, PC3. It's on the same network, IP version 6. Let's go ahead and ping that. Once again, PC3 right here is the global unicast address of it. That's the address I'm going to ping. Ping 2001 :db8 :1 :20. That successfully works. So we have connectivity. We have connectivity to PC3 from PC2 to PC3. I'm going to go ahead and close that. Now we have to go and check connectivity to the other IP version 6 network. From PC2, I'm going to go ahead and ping laptop B. Open up PC2, make the window a little bit bigger, open up our command prompt, and now we're going to ping, and then what was the device again? Laptop B. Here's laptop B and its IP version 6 global unicast address, the GUA. I'm going to go ahead and type that in, 2001 :db8 :5 :10. Okay, it's coming back saying destination host unreachable. Now it's even timing out. We have 100% loss, so there is a problem. Well, once again, when we had a problem trying to ping the destination, we came back and used ICMP's traceroute to help us identify at least the area where the problem was. And so the command once again here is trace RT space and then the IP address that we're trying to reach, 2001 :db8 :5 :10. Wow. And now we're starting to have problems. We got through the first hop successfully, but then the second hop, we have problems. It's airing out. And so let's go ahead and see if we can figure out what's happening. From PC2, we made it through the first hop, which was router 2, but then after that, we started having problems. So the problem is somewhere after router 2. We made it through the first router, but then the rest of it, there's problems somewhere. And let's go ahead and take a look at that. I'm going to go ahead and close that. The next device after router 2, what we should be getting here is router 1. I'm going to go ahead and click on that, and let's look at the configuration of that. Make the window a little bit bigger. Go ahead, log in. There's no passwords for this exercise. Type enable to get into privileged exec mode. And then I'm going to do a show IP version 6. Once again, we're dealing with the IP version 6 network, so it's show IP version 6. Interface brief. And here we have the information. And I'm just going to compare it to our addressing table. Router 1, gig 00. Here is the here's the address information for that. We have 2001 db8:4:1. That's what we have. We have a self-assigned link local address, so that's fine also. So it looks like gig 00 is fine. Serial 010. Serial 010 has an IP address here. 2001 db8 2:2. 2001 db8:2:2. That looks correct. And then serial 011. Serial 011 up here from our addressing table has an IP version 6 address of 2001:db8:3:1. And down here from our show IPv6 interface brief, we have 2001 db8:3:1. Well, all of those seem to work. All of those are correct. All the statuses are up for those interfaces. That looks like it's going to work. If we look here, all the information on router 1 is correct, but we can't get past there. We can't get past it. And so it might not be with the next device. Maybe it's the other device, because this is a point-to-point connection between router 1 and router 3. That's a point-to-point connection. And if either end of that connection is down, that entire network is down. And so it looks like router 1 is okay. We're going to have to come in and look at router 3 and see how that is. I'm going to go ahead and close router 3 out here, or sorry, router 1. And then I'm going to click on router 3, slide that over. I make the window a little bit bigger, right to left. Go ahead, log in, get into privileged exec mode by typing enable. And then we'll do the show IPv6 interface brief, lists out our information. Here is our information for router 3. Gig 01 or gig 000 is unassigned, but yet here's an IP address. Remember, we entered IP version 6, so it's only giving us the IP version 6 information. This is an IP version 4 address. That makes sense then. Gig 001, here is the IP version 6 address of it, 2001:db8:5:1. Gig 00, 2001 db8:6. But over here it says it should be :5. Oh, so right here it has a wrong number. That's going to make it a wrong network. We need to go in and correct the IP version 6 address here on gigabit Ethernet 0/0/1. Let's look at serial 00 interface. We have 2001 db8:3:2. 2001 db8:3:2. That looks correct. Once again, we have to go in and correct this IP version 6 address here on gigabit Ethernet 0/0/1. Okay, so it has the wrong address. Now with IP version 6, to change the address, you actually have to delete that address and then enter in the correct address. We are in privilege exec mode. You can tell that because of the pound sign here, or the hashtag, or my personal favorite, the waffle sign. We need to go into global configuration mode, so I'm going to go ahead and type config T. Now we need to go into the interface. Once again, the interface we're looking at is gig Ethernet 0/0/1. So interface space G0/0/1. And we need to remove that IP address, the bad address, and then once we remove it, we can add in the new one. And how we remove a command in the Cisco iOS is we put the word no, and then we put the command or the line we want to remove. And what that means here is I'm going to go ahead and type no, and then IPv6, because it's an IP version 6 address, the keyword of address, and now I'm going to put in that wrong address that we want to remove, this 2001 DB8:6:1. 2001:DB8:6, that was the wrong number right there, :1. Oh, I spelled IP version 6. So what I did is I hit the up arrow, the left arrow, moved it over, delete the character, hit enter, and I forgot my space. Hit the up arrow again, move the left arrow over, put my space in, hit enter. Now it says an incomplete command. And this is a process you go through. You forget little things. I spelled IPv6 wrong the first time. I forgot a space. Now I have an incomplete command. If I use the up arrow and put a question mark there because it's an incomplete command, it shows me here that it's looking for a word, an IP version 6 address, but it's also looking for the prefix, the slash number after it. Well, the slash number we're always using right now, or the slash number we are using, is right here. It's a /126. Sorry, it's a /64. I had the wrong address. So on router 3 here, it's a /64. I'm going to go ahead and put in a /64. And once again, in Cisco fashion, no news is good news. Notice every time I entered the command wrong before that, it made sure to tell me. This time I entered it correctly, it didn't say a word. So I entered that command in correctly. Now we've removed that IP address. Let's go ahead and enter that IP address in correctly. IPv6 space and then the keyword of address, and then our correct address. Our correct address is over here, 2001:DB8:5:1. 2001:DB8:5:1. And of course we need to put our prefix in there, /64. There you go. Our address is now in correctly. If I exit out, takes me to privileged exec mode. Let me do a show IPv6 interface brief. We can confirm that the correct IP version 6 address is in here. That is matching our addressing table. I'm going to go ahead, close out the router 3 window. Okay, let's go back and try to ping what wasn't working before. We are on PC 2 and we are trying to ping laptop B. Here in my command prompt, I'm going to go in, type in ping, and then laptop B. Here is the IP version 6 address. 2001:DB8:5:10. Oh, I forgot a double colon. Windows will yell at you too. I forgot my double colon right before that last number. Destination unreachable. Okay. Let's look and see what we did. We changed an IP address here on router 3. On router 3, the router routes information, and so it has a routing table. What we might have to do is go back into router 3 and take down that interface. And so we went in there and we changed the interface value on router 3 of gig 001. What we might have to do is shut down gig 001 and then restart it, and that way the routing tables will get updated. And so what I'm going to do is click on router 3 here. If I do a show IP route, we can notice here that the information shows we are directly connected. It should be working, but let's just go ahead and shut it down. So I got to get in global configuration mode, go into the interface of G. What interface was that again? G001 0/0/1. Do a shutdown on it. Notice we go administratively down. We change line protocol to down. Now let's do a no shutdown. Turn that back on. Let's activate that interface. We both go up and up. Go over here back to PC2 and ping that address again. I can use the up arrow to repeat that last command. And we are still failing. Why are we failing? Oh, we are still negotiating a connection here because we shut it down and then we brought it up. We had to wait until that amber light, you saw it was amber for a little bit, and then it turned green, and right when it turned green, that last one worked. Let's go ahead and try it to ping again. Up arrow. And there it is. Once we negotiated our port connection, we have the right routes in the routing tables. It is working. And so we were able to ping laptop B from PC2. And the last one we have to ping here is from PC2. We have to ping laptop C. And so we can go in here and type in ping and look at laptop C's IP version 6 address, which is right here. And that gives us 2001 DB, DB8:5:20, and that one successfully works. All of the end devices were successfully able to connect to all the other end devices. The other thing here in the packet tracer, if we look in the bottom right corner of our packet tracer activity, we can see that we are at 100% completion. I'm going to go ahead and click on check results. And then on the 3 tabs up here, I'm going to go ahead and click on assessment items. And if you notice, there was several errors we had to fix. On PC4, we had to fix that default gateway. We found that, we fixed that. On router 3, there was an issue with the gig 001 interface. It had the wrong IP version 6 address. We went in there and fixed it. We set the prefix length correctly. Then on server 1, we had a couple issues. The default gateway was wrong. The fast Ethernet was wrong. We went in there and we fixed all of that information. Those are the only problems we had on the network. We are at 100% completion. That was Packet Tracer Lab 13.3.1. Use ICMP to test and correct network connectivity. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.